Hi, my name is Martina Zambelli. I'm a research scientist at DeepMind. Today, I'm presenting a work done in collaboration with Yusuf Aytar, Francesco Visin, Yuxiang Zhou, and Raia Hadsell, titled Learning Rich Touch Representations Through Cross-Modal Self-Supervision. Self-supervision has seen great advances in the last times in several domains, such as vision, language, and sound. However, less progress was made using the tactile modality. We contribute to this field by introducing two datasets collected with simulated shadow hand and containing multimodal data that include the sense of touch. We also propose a learning pipeline to learn rich touch features using cross-modal self-supervision. Why is touch so interesting? Well, in several occasions, vision is actually not available and touch becomes very important to solve some task. In doing this, a mental model of the object of interest is still available. We believe this is very relevant in robot manipulation too, where occlusions and limited visual capabilities are likely. We argue that vision alone may not be sufficient for dexterous manipulation tasks, and that cross-modal representations can enhance robot manipulation skills. In this work, we collected data from a simulated shadow hand interacting with several different objects. We used vision, touch, and proprioception to pre-train a representation for touch features using cross-modal losses without supervision. We then evaluated our learned features on few-shot object classification and pose estimation. To learn touch features, we exploit naturally existing correlations between touch, proprioception, and vision. The learning architecture is shown in this diagram. Each visual frame is processed through a convolutional encoder. Touch and proprioception are processed through an MLP and an LSTM, which captures the dynamics information. Touch features are then learned using cross-modal self-supervision. To do so, we use different methods, including temporal contrastive networks, cross-modal distance classification, as well as variants of contrastive predictive coding. Another method that we evaluated is cross-modal generation, which relies on visual input reconstruction to train the touch representations. Finally, we evaluated the learned features on few-shot classification, using an LSTM and an MLP to generate labels from features. To collect the data, we ran an MPO agent to control the hand movements. The agent was blind and rewarded by contacts between the fingertips and the objects, while it did not receive classification score, which were only used for feature evaluations. We collected two datasets, one using YCB objects, as shown in the first row of these videos, and one using props of different shapes and sizes that can be either rigid or deformable, shown in the second row of videos. For YCB objects, we changed the orientation of each object, while props were kept fixed. We evaluated each method on increasing number of samples and compared it with learning from raw data. Cross-modal generation achieved the best accuracy on few-shot object classification, achieving a 20% gain compared to learning from scratch. Other methods showed comparable performance, and this result holds for both datasets. We also evaluated learning features on unseen data. Here, contrastive methods perform the best. They are still better than learning from scratch and outperform cross-modal generation, which is based on visual reconstruction and is now the worst as it is overfitting to the specific dataset. Finally, the learned features also improve pose estimation accuracy. Discriminating orientation from vision is hard, and cross-modal generation doesn't provide robust features in this case either, while contrastive methods perform the best in this more complex task. To summarize, we propose a pipeline to learn touch features and cross-modal self-supervision. We compared several existing methods and cross-modal variants. We evaluated the learned features on few-shot object classification and pose estimation, finding that contrastive methods perform better on more complex tasks. Finally, we also released two datasets, hoping to foster more research in this field. With this, I would like to thank you for your attention, and please do get in touch if you have any questions or if you're interested in this work. Thank you.